Section 16 of Familiar Letters on Chemistry by Justus Liebig. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to find out how to volunteer, please contact LibriVox.org. Recorded by Peter Yearsley. Familiar Letters on Chemistry. Letter 16. My dear Sir, my recent researches into the constituent ingredients of our cultivated fields have led me to the conclusion that of all the elements furnished to plants by the soil, and ministering to their nourishment, the phosphate of lime, or rather the phosphates generally, must be regarded as the most important. In order to furnish you with a clear idea of the importance of the phosphates, it may be sufficient to remind you of the fact that the blood of man and animals, besides common salt, always contains alkaline and earthy phosphates. If we burn blood and examine the ashes which remain, we find certain parts of them soluble in water and others insoluble. The soluble parts are common salt and alkaline phosphates. The insoluble consist of phosphate of lime, phosphate of magnesia, and oxide of iron. These mineral ingredients of the blood, without the presence of which in the food the formation of blood is impossible, both man and animals derive either immediately or mediately through other animals from vegetable substances used as food. They had been constituents of vegetables. They had been parts of the soil upon which the vegetable substances were developed. If we compare the amount of the phosphates in different vegetable substances with each other, we discover a great variety, whilst there is scarcely any ashes of plants altogether devoid of them; and those parts of plants which experience has taught us are the most nutritious contain the largest proportion. To these belong all seeds and grain, especially the varieties of bread corn, peas, beans, and lentils. It is a most curious fact that if we incinerate grain or its flour, peas, beans, and lentils, we obtain ashes which are distinguished from the ashes of all other parts of vegetables by the absence of alkaline carbonates. The ashes of these seeds, when recently prepared, do not effervesce with acids. Their soluble ingredients consist solely of alkaline phosphates; the insoluble parts of phosphate of lime, phosphate of magnesia, and oxide of iron; consequently of the very same salts which are contained in blood, and which are absolutely indispensable to its formation. We are thus brought to the further indisputable conclusion that no seed suitable to become food for man and animals can be formed in any plant without the presence and co-operation of the phosphates. A field in which phosphate of lime, or the alkaline phosphates, form no part of the soil, is totally incapable of producing grain, peas, or beans. An enormous quantity of these substances indispensable to the nourishment of plants is annually withdrawn from the soil and carried into great towns in the shape of flour, cattle, etc. It is certain that this incessant removal of the phosphates must tend to exhaust the land and diminish its capability of producing grain. The fields of Great Britain are in a state of progressive exhaustion from this cause, as is proved by the rapid extension of the cultivation of turnips and mangel-wurzel, plants which contain the least amount of the phosphates, and therefore require the smallest quantity for their development. These roots contain 80 to 92% of water. Their great bulk makes the amount of produce fallacious, as respects their adaptation to the food of animals, inasmuch as their contents of the ingredients of the blood, i.e. of substances which can be transformed into flesh, stands in a direct ratio to their amount of phosphates, without which neither blood nor flesh can be formed. Our fields will become more and more deficient in these essential ingredients of food in all localities where custom and habits do not admit the collection of the fluid and solid excrement of man and their application to the purposes of agriculture. In a former letter I showed you how great a waste of phosphates is unavoidable in England, and referred to the well-known fact that the importation of bones restored in a most admirable manner the fertility of the fields exhausted from this cause. In the year 1827 the importation of bones for manure amounted to 40,000 tons, and Huskisson estimated their value to be from £100,000 to £200,000 sterling. The importation is still greater at present, but it is far from being sufficient to supply the waste. Another proof of the efficacy of the phosphates in restoring fertility to exhausted land is afforded by the use of the guano, a manure which, although of recent introduction into England, has found such general and extensive application. We believe that the importation of 1 cwt. of guano is equivalent to the importation of 8 cwt. of wheat. The 1 cwt. of guano assumes, in a time which can be accurately estimated, the form of a quantity of food corresponding to 8 cwt. of wheat. The same estimate is applicable in the valuation of bones. If it were possible to restore to the soil of England and Scotland the phosphates which during the last 50 years have been carried to the sea by the Thames and the Clyde, it would be equivalent to manuring with millions of hundredweights of bones, and the produce of the land would increase 1/3 or perhaps double itself in 5 to 10 years. We cannot doubt that the same result would follow if the price of the guano admitted the application of a quantity to the surface of the fields containing as much of the phosphates as have been withdrawn from them in the same period. If a rich and cheap source of phosphate of lime and the alkaline phosphates were open to England, there can be no question that the importation of foreign corn might be altogether dispensed with after a short time. For these materials England is at present dependent upon foreign countries, and the high price of guano and of bones prevents their general application, and in sufficient quantity. Every year the trade in these substances must decrease, or their price will rise as the demand for them increases. According to these premises, it cannot be disputed that the annual expense of Great Britain for the importation of bones and guano is equivalent to a duty on corn, with this difference only, that the amount is paid to foreigners in money. To restore the disturbed equilibrium of constitution of the soil, to fertilize her fields, England requires an enormous supply of animal excrements, and it must therefore excite considerable interest to learn that she possesses beneath her soil beds of fossil guano, strata of animal excrements, in a state which will probably allow of their being employed as a manure at a very small expense. The coprolithes discovered by Dr. Buckland, a discovery of the highest interest to geology, are these excrements, and it seems extremely probable that in these strata England possesses the means of supplying the place of recent bones, and therefore the principal conditions of improving agriculture, of restoring and exalting the fertility of her fields. In the autumn of 1842 Dr. Buckland pointed out to me a bed of coprolithes in the neighbourhood of Clifton, from 1/2 to 1 foot thick, enclosed in a limestone formation, extending as a brown stripe in the rocks for miles along the banks of the Severn. The limestone marl of Lyme Regis consists for the most part of 1/4 part of fossil excrements and bones. The same are abundant in the lias of Bath, Easton, and Broadway Hill, near Evesham. Dr. Buckland mentions beds several miles in extent, the substance of which consists in many places of 1/4 part of coprolithes. Pieces of the limestone rock in Clifton, near Bristol, which is rich in coprolithes and organic remains, fragments of bones, teeth, etc., were subjected to analysis, and were found to contain above 18% of phosphate of lime. If this limestone is burned and brought in that state to the fields, it must be a perfect substitute for bones, the efficacy of which as a manure does not depend, as has been generally but erroneously supposed, upon the nitrogenised matter which they contain, but on their phosphate of lime. The osseous breccia, found in many parts of England, deserves especial attention, as it is highly probable that in a short time it will become an important article of commerce. What a curious and interesting subject for contemplation! In the remains of an extinct animal world, England is to find the means of increasing her wealth in agricultural produce, as she has already found the great support of her manufacturing industry in fossil fuel, the preserved matter of primeval forests, the remains of a vegetable world. May this expectation be realized, and may her excellent population be thus redeemed from poverty and misery. The end of section